So the first four, I'm going to go through the first two to start, and then I'll take questions, is completing the square. So our first step is making sure there is a 1 in front of the x squared. In this problem here, there's a 1 in front of the x squared, so I can skip that first step, move to the second step, which is adding my constant to the other side. So now we're at x squared plus 8x equals 20. Now comes the trick. And the trick is taking half the middle term and squaring it. Half of 8 is 4, and 4 squared is 16. And if I add 16 to one side, I need to do it to the other. That's literally the trick or the manipulation of the problem. We're always going to take half the middle term, which is 4, and square it. That number will always be positive, and we add it to both sides. Now I factor what's left. You can factor it, but it will always be a binomial squared when you take half the middle term and square it. And it's always going to be the same sign here and half the middle term. So it's x plus 4 squared equals 36. Now it's two more steps. We've got to get rid of the square. So we get rid of a square by taking the square root. And I'm left with x plus 4 without a square, and it's plus or minus 6. And the problem finishes with negative 4 plus or minus 6. Now, if you can simplify even more, do so. Negative 4 plus 6 is 2. Negative 4 minus 6 is negative 10. And that's my complete answer. Second one, I don't have a 1 in front of x squared, so I need to get it. So we divide everything by 2 first, including the 0. Even though it doesn't have a major effect on the problem, it's still good habit and good math technique that if I divide something by 2, I got to divide everything by 2. I've got to be consistent. So whatever's in front of that x squared when we're completing the square, I need to divide every term by that number. In this case, it's 2. If it's a different number, you don't automatically divide by 2. We're dividing by the term in front of x squared to create this 1 here. Now, I'm going to subtract 14 on both sides. X squared minus 6x equals negative 14. We do half of negative 6 and we square it. Half of negative 6 is negative 3. Negative 3 squared is 9. So we add 9 to both sides. We're going to factor what's left. In this case, it's x minus 3 squared. So essentially, half the middle term, and we keep its sign. In this case, it's negative 3 equals negative 5. We take the square root of x minus 3 squared and the square root of negative 5. Take the square root of something, the exponent disappears, and we simplify this radical. In this case, you can't break down root 5, but when you have a negative, it comes out root 5. And then we finally finish up by adding 3 to both sides. And when I add 3 to both sides, we end up with x equals 3 plus or minus I root 5. And that's how you're going to leave your answer. So in this case here, I'm going to divide everything by 5. You have to have a 1 in front of your x squared. This becomes x squared minus 10x plus 2 equals 0. And that makes your number smaller, which makes it easier as well. We subtract 2 on both sides. Half of negative 10 is negative 5. And negative 5 squared is 25. We factor what's here. X minus 5 squared equals 23. I'm going to take the square root of both sides. That's how I get rid of the square. So x minus 5 equals plus or minus root 23. If you can't simplify the radical, leave it. And trust me, leaving it is easier. 5 to both sides, my answer is 5 plus or minus root 23. My second one, there's a 1 in front of the x squared. I don't need to simplify. So I subtract 30. X squared plus 16x equals a negative 30. Half of 16 is 8, and 8 squared is 64. So I add 64 to both sides. This factored is x plus 8. It's always half the middle term with that sign. Equals 34. We're going to take the square root of x plus 8 squared. Take the square root of 34. So x plus 8 equals plus or minus the square root of 34. And then we finish by subtracting 8 on both sides. And this is what our answer looks like. If you can simplify the radical, you do so. If you can't, you leave it. We are going to be working with just b squared minus 4ac and its relation to 0. If it's greater than 0 and a perfect square, 2 rational solutions. If it's greater than 0 and not a perfect square, 2 real solutions. Equal to 0, a double root. Less than 0, regardless of whether it's perfect square or not. It's less than 0, it's 2 complex solutions. So here, you can divide a 5 out of here if you want to make all your numbers lower, or you can just work with the numbers as is. It's really up to you. I'll work with them as is here. 30 squared minus 4 times 5 times 45. 30 squared is 900. 4 times 5 is 20. 20 times 45 is 900. We get 0. My answer is 1 double root. I'm going to circle my answer like that's what I want written down. And for all these, I'm going to write my a equals 3, b equals 5, c equals 8 to the side, so there's no mix-ups. Okay? So we're going to have 5 squared minus 4 times 3 times 8. Well, in this case, we get 25 minus 12 times 8 is 96, and that becomes a negative 71. So this means 2 complex solutions because, or roots, you can say either one. Okay, because my radical is a negative. So now the next one, a equals 2, b equals negative 13, and c equals negative 4, right? We always keep our signs. So negative 13 squared minus 4 times 2 times a negative 4. Negative 13 squared is 169. 4 times 2 is 8. 8 times a negative 4 is negative 32. When you subtract the negative 32, it becomes plus 32. And this becomes 201. So that means 2 real roots or real solutions. I'll write real roots here. Okay? Because I'm getting a number that's not a perfect square. My last one, a equals 1, b equals negative 8, and c equals 4. Negative 8 squared, the b squared always becomes positive, minus 4 times 1 times 12. Well, that's 64 minus 48, and that's 16. 16 is a perfect square. So not only is it greater than 0, it's a perfect square, so the roots are rational. Because the radical goes away. When there's a radical left behind, that means you're going to have complex roots if it's negative, or real roots if it's positive. If we can get rid of the radical because it's a perfect square, we get rational solutions.